right, we are starting a new unit today. We're starting our polygons unit. So in your classroom, you have a notes page with the blue header page, and then the pages after that where you're going to link your notes. So I need you to link that into your notebook cover. So if you search in your Google Drive for cover, notebook cover, you should be able to link that as the PG tab. Okay, and then come back here and we'll go through some notes today. All right, we're going to start with some old stuff. Should be nice and easy. We classify polygons by the number of sides it has. You all know that. Some of the newer ones, you've got heptagon, decagon, dodecagon. We talked about things that are regular, are both equilateral and equiangular. So they have all the same sides, like that, and all the same angles. And we remember that if I use the same tick mark, it means those lengths are the same. If I use the same angle arc, then those angles are the same. So if I use different tick marks, it indicates that the sides are different. And if I use different angle arcs, it indicates that the angles are different. So irregular polygons are anything that's not where everything's equal. Okay, then we have concave and convex. Your convex polygons are your normal polygons. All regular polygons are going to be convex, where all the vertices are pointing outwards. And concave polygons have these cave-ins, where you have a vertex that's pointing inward, and it gives you an angle on the inside that's more than 180 degrees. All right, then we have consecutive vertices. And this is a new phrase. Consecutive vertices are just any two vertices that are right next to each other. So like B and C are consecutive, C and D are consecutive, E and D are consecutive, and so on. And then a diagonal is a segment that connects any two non-consecutive vertices. Now, when most people think of a diagonal, they think, okay, I've got to divide it equally into two. So I've got a couple of diagonal options. Well, that's not the only option there. You can also do something like this. It's any non-consecutive vertices. So I can connect these all over the place. Let's look at the pentagon because it's got less going on. A to C is a diagonal. A to D is a diagonal. Any non-consecutive vertices are considered diagonals. They don't have to divide the shape into two equal parts. Okay, we've talked a little bit about interior and exterior angles before when we were doing triangles. Interior angles are just on the inside, and exterior angles are made by extending a side, and then it's the angle that is formed with the next side. So you've got two rotations here of the same shape. They've just extended the sides in different directions. Okay. The interior angle sum is when you add up all of the angles on the inside. So let's talk triangles because we're used to triangles. If I added up these three angles, it would add up to 180 degrees. Well, what about in the quad? What if I added up these three angles? What's it going to add up to? Well, some of you already know that it's going to add up to 360. But I want you to watch. We can divide this quadrilateral into two triangles so that so I've got these two triangles that the angles are all located on the outside. So I've got angles here, angles here, angles here. You can kind of see that color. Angles here, 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 and here. So all of my angles of those triangles are located on the outside. There's two triangles, each at a 180. Well, 180 plus 180 is 360. If we take a look at a pentagon and we cut that into triangles, I could get three of them. So I got 3 180-degree triangles, which is 540 degrees. So the 5 angles of a pentagon add up to 540 degrees. For a hexagon, we're going to have the same thing, except I'm getting 4 of them. So I'm going to add up to 720 degrees. Okay, so we're going to stop there. So it's a pretty light day. You have this assignment in your Google Classroom. Identify the name or the type of the polygon by name. And then do a little drawing for me. Convex hexagon, concave dodecagon. Interesting things like that. All right, take some time, work on that, and I will see you the last 10 minutes of class.